Hello, everyone. Welcome back to another week here at City Tutoring. It's been a rather rough past few days. We've got ice storms here in Lynchburg, Virginia. I'm telling you all, it's been a really bad winter. I can't wait for spring. It's been one of the roughest winters I can remember. But we were discussing the set theory and operations with set. So this video is going to kind of wrap that up because in the next video on logic, we're going to be discussing ordered pairs. But before we do anything like that, I want to talk to all you young people, math scholars, and just lovers of logic around the world. I want to welcome you all back, but I'm celebrating with you because today we celebrate a victory, and not just for this channel, but for Reason itself, because we are now over 22,600 subscribers strong. Praise God for that. I'm going to link the video below because just a few weeks, not even a full 2 weeks ago, we were only at 10,000. So I praise you all for your support. I really do appreciate it. That's why I'm here working for you. You know, we live in a world where common sense is really under attack. But here, I think all of you who have subscribed, I believe that you appreciate that we stand firm. We must stand firm on the foundation of truth, numbers, and the beauty of mathematics. And what better way to mark this milestone than by diving into continuing with our set theory, which is really the bedrock of truly rigorous mathematics, where order must prevail and chaos is tamed by logic, by intractable logic. So go get your coffee, if you must, hopefully brewed the right way, in a good old-fashioned percolator at least. None of this made in China. That's not in my house. We're going to have made in China Keurig nonsense, that it turns coffee into a chemistry experiment. Just classic roast American coffee, the way it was meant to be. And we're going to dive into set theory. By the way, speaking of a percolator, if you don't know what I'm talking about, this is what I use. This is what I use right here. This is over 100 years old, and it still works. It works very well, and you can see already. This one is actually electric. This one's actually electric. But I have another one in case power goes out or anything like that. And it's you put one of those butane burners on the bottom, and it works wonderfully. Percolates just as good. We can be off grid. Our ancestors were off grid, and they did just as actually they did better in many ways than we do today. So anyway, wanted to show you that, and we need to get back to work. All right, so in the previous video, we did not discuss, I mentioned this because we really didn't discuss I wanted you to just make a note of this. You see how on the top here, I have within the braces, you can write that as in a shorter way as x is an element, a member of the real numbers, and 0 is less than x, x less than 1. So just be familiar with that. You don't have to write all of that on the top there. But I am assuming you've watched the previous videos. Also, I want you to just keep in the back of your mind, be familiar with intervals. Be familiar with intervals. So you have the one with the brackets, that's what's called a closed interval. The one with the parentheses, the AB, that is an open interval. And then you have semi-closed or semi-open, depending on and that has a bracket and a parentheses. I mentioned that also in my video on inequalities, which is when I showed a lot of how these intervals are used. But anyway, we also have unbounded intervals, a to infinity, etc. But just have that in the back of your mind. We're not going to look at that right now, though. But here's an interesting theorem. Let A be a set. Then an empty set is a subset of A. I want you to think about a proof of that in your mind, and then we're going to talk about it. Remember, this section, we're discussing operations with logic, set operations, basically, before we get into ordered pairs in our next video and all that. So just have that in mind. Think of a proof of that. Right, so hopefully you thought about the proof. And here is the actual, see if it's similar to this. You have here the empty set, the ever reliable but absentee, so to speak. So we have to demonstrate the validity of the implication that if X is an element of the empty set, then X must be an element of A, right? But we also know that a null set, an empty set, has no members, right? It's probably about as barren as the ethics of your average congressman in the United States. You have the antecedent, which is which means that X as an element of an empty set is always false. And we have the ironclad rules of logic, which are also the logical rules given to us by God himself. And a false premise leads to a vacuously true conclusion. And the statement, because of that, the statement holds universally because it's a vacuously true conclusion. And behold, you have a theorem that is airtight, that even people who would try to go against it would have difficulty in doing so, at least logically. And mathematics is very much like civilization, like a true civilization. It thrives on order, it thrives on structure, and the judicious application of the logical rules. And just as society is built on the careful delineation of rights, obligations, and we have sacred boundaries as well of personal, private property, so too does set theory. It organizes what it does, the abstract chaos, into a refined hierarchy of relations. And to this end, we have to introduce now there are really three, I guess we could say, fundamental operations. We have union, which I hope you're familiar with because I've been mentioning it in previous videos, intersection, and complementation. And each of those serves a vital role in maintaining the mathematical propriety that we need. So you have the union, first of all, right? The union of A and B, bringing all the elements together. It's a grand coalition, a big tent approach to set membership. Certainly you want to avoid that kind of approach in some areas of life. You certainly wouldn't want to have a grand coalition when it comes to morals, right? You don't want to make something, I find it interesting, by the way, how a lot of people, they're always talking about coming together, even amongst with people who are clearly in error. When you take food, even one tiny bit of contaminated food will taint the rest of your food. It will make you sick. So I don't understand how people can say that they have no problem with bringing into their organizations people who are clearly unrepentant in their errors, especially when you do have a clear definition of what the standards are. We're living in an age, and this has been happening in the Western world ever since the tragedy of the 1960s. Ever since the 1960s, there's been a push, an infantile push towards more unity, at the expense of truth, by the way. And it's a humanistic goal. It's not based on anything Christian, by the way, and it's certainly not based on the rules of logic. We all have to have a certain standard. We're all very different in many ways, and we have to maintain those standards in order to have a civilization. But this whole push to be, I don't know what they talk about one world. There used to be a dream about one world government. It's ridiculous. It's preposterous, and it's also anti-Christian, by the way. Every time men have tried to unite in some way, in that sense, God has come down and to strike it down. We have the Tower of Babel, for example, for that. But anyway, I'll continue because then I get people who are always the whiners and they complain that, oh, you should stick to this. I do what I want on my channel, by the way. I really do. And I think most people have gotten used to it. And I think most people are like the fact that I am not going to apologize for expressing what I believe to be fundamental truths. I've said it many times before. Why are you on a math channel? Why are you participating in a math channel if you don't care about truth? Math is truth. It is based on fundamental truths. The second thing here is the intersection. The intersection is really an elite circle, you can think of it that way, of elements that they have to meet both sort of stringent membership criteria. But in more plain talk, they are members of both. There's a commonality between them. And you could think of it as cutting down, so to speak, your set. And then you have the complement, which is really the decisive expulsion of, I guess you could call it undesirables. It's mathematical border security at its finest. We could sure use more border security in the United States and in the Western world in general. It's chaos. People just pour through the border like there's no tomorrow and no consequences at all. We don't even know, in many cases, we don't know who is in the country. They could be terrorists, they could be all sorts of criminals, undesirables. No one knows who they are. In fact, there have been cases where it took the authorities a while to track people down who had committed very heinous, evil, violent crimes against innocent people, and it took them a long time because a lot of these people they're completely without any kind of identity at all. So anyway, should it happen that the intersection of A and B is an empty set, then we declare A and B to be disjoint, and it's a term you might argue applies equally well to two gentlemen perhaps of opposite political temperaments, who are attempting to discuss current affairs over coffee or tea or other substances. So, the foundations of set theory really mirror the great principles of classical thought. Order should prevail over chaos, logic should triumph over the whimsy. And if the empty set teaches us anything, it is that silence can sometimes be the most powerful argument. But we have more to say about these things, so let's look at the following principles as well. All right, we have to discuss also that these correspond, what we just said, to the basic, what we call logical connectives. We discussed logical connectives in my previous videos, by the way, but this is what they look like written out. I typed everything before that, again, that way people, because you were right, thank you. Somebody pointed out, they said that way we don't waste as much time with me having to actually type all the notes again. But this is the what you should be looking at. Now, the thing is, the idea of complementation, it might seem a bit complicated, because why didn't we just define not the negation of B to be just X is not an element of B? So we have a problem here of size. We have a problem of size. Now, if we take this example here, let's say B is 2, 4, 6, and 8, right? If you try to define it, you really end up with an extravagant collection, and that includes far more than you could ever want. I mean, you could have the integers 1, 3, 5, 7, 9, 11. You could have the real numbers greater than 50, perhaps. You could have a function, x squared plus 3, because why not? I mean, it could be part of the club. You could have Harvard Square. You could even have Bernie Sanders. Even he gets an invitation, but don't worry, he won't stay for long. Not around here, he won't. So if you wanted to stick to a sensible mathematical discussion, it's reasonable to say that those integers like 1, 3, 5, 7 should be and not be. And maybe we could entertain other ideas, but I mean, it's just so broad. I mean, Bernie Sanders, really? Surely that name has no place in a serious mathematical discussion. So the key here is context. Very important, the context. Just as you would not randomly invite Bernie Sanders to a tea party, unless, of course, maybe you would. Maybe you're a fan of socialist undercurrents. But mathematical concepts and proofs live within the confines of a system. And that's where the universal set comes in, because the universal set acts as the adult supervision in this chaotic dance of sets. The universal set is the big picture. It contains everything that's relevant to the discussion at hand. So when you're faced with defining the complement of a set, just remember it's all about choosing the right context and maybe, perhaps, keeping Bernie Sanders out of it. Let's keep our sets pure, people. And we continue the discussion because now we look at a little bit of an exercise. All right, we continue. if these are your sets here, A, B, C, and D, and these are the elements in the set, then if you have a look at these, the following can also be all true. In other words, A can be a subset of C, but A is not a subset of B. 5 is an element in the set B for sure. And then 1 is one is not an element of D. Why is that? Because 1 would not give you 0 when you plug it in. B equals D, right? 3 and 5 satisfy the condition in D, and 5 can be the subset of B, and B cannot be equal to C. They are separate sets. Just something to think about. Now, what about a more advanced style of proof? I put in here, see what you think about this. I put some blanks in here. I want you to read this, and I want you to complete the proof by filling in the blanks. So pause the video and let me know what you get. Have a look at this. These are all these blanks. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's about 9 of them. 9 blanks, actually. And see what you come up with. Think about it. All right. Check your answers. This is the full proof. I'm not going to read it out loud because you can read it on the screen. But see how many you get correct out of these. See if your proof matches with these answers. Notice that there's a little diamond-looking thing at the end. That's a standard notation when you have completed your proofs in mathematics. Get into the habit of doing that, or sometimes you can fill it in. Usually, what I used to do as an undergrad would be just to sign my name, my initials, AC. So, or you could put a rectangle, small rectangle shaded in. There's multiple ways, but it's standard to do that. All right. The other thing, so when we come back in our next video, we will continue with set operations. And there's a few other things one more thing about set operations that I wanted to do. And then we will discuss ordered pairs. We're going to talk about ordered pairs as well. Tomorrow, I'm going to try, assuming that I have everything is okay with the internet connection due to the storms and all that. I will post another one of those fascinating problems of math that you all enjoy. By the way, thank you all as always. Please continue to support the mission of this channel. I appreciate you all. The proof is that there are a lot of people coming into the channel and you have appreciated what we do. So if you're new here and you see this video and you like what you hear, you like our commitment to truth, uncompromising truth, and unapologetically so, then this is the right channel for you. If you're made out of jelly, though, if you're easily offended, if you're that type of person, you're not going to be happy here. Thank you all, and God bless.